We want to use a linear approximation or a tangent line to approximate this quotient here, 1 divided by 0.504. To do this, we'll let f of x be the basic rational function 1 divided by x, and we'll use the tangent line near a point x equals 0.504. So again, we'll be using the basic rational function f of x equals 1 divided by x. We want to select an x value that's close to this x value, but easier to work with. So we'll find the equation of the tangent line at x equals 0.5. 5/10 is equal to 1/2. So the idea is we'll be using the equation of this red tangent line at x equals 0.5 to approximate the function value when x equals 0.504. Notice how as long as x is close to 0.5, the linear equation will give us a good approximation for the true function value. So to find the equation of the tangent line, we'll have to find the point of tangency, or a point on the line, and also the slope of the tangent line. Well, because we're using x equals 0.5 or 1/2, that would be the x-coordinate of the point of tangency. And now to find the y-coordinate, we'll substitute 1/2 into our function f of x. So f of 1/2 would be equal to 1 divided by 1/2, which is equal to 1 times the reciprocal of 1/2, or 1 times 2, which is equal to 2, which means the y-coordinate of the point of tangency is positive 2. And now we'll find the slope of the tangent line at x equals 1/2 by finding the derivative function and evaluating the derivative function at x equals 1/2. So let's rewrite function f as f of x equals, this is 1 divided by x to the first, so if we move this up, it would be x to the power of -1. And now we can apply the power rule to find our derivative function. F prime of x would be equal to -1 times x to the power of -1 minus 1, that'd be -2. This would be -1 divided by x to the second. If we make this a fraction and move this down to the denominator, it changes the sign of the exponent. And therefore, the slope of the tangent line would be equal to f prime of 1/2, which would be equal to -1 divided by 1/2 squared. Well, 1/2 squared is 1/4, so we have -1 divided by 1/4, or times 4/1, which is equal to -4. So the slope of our tangent line at x equals 1/2 is -4. So now that we have the point of tangency and the slope of the tangent line, we can find the equation of the line and then make our approximation for the given quotient. Using point-slope form of a line, or the form y minus y sub 1 equals m times the quantity x minus x sub 1, notice x sub 1 would be 1/2, y sub 1 would be 2. So we'd have the equation y minus 2 equals -4 times the quantity x minus 1/2. Now we'll distribute and solve for y. So if we distribute, we'd have y minus 2 equals -4x, and then we'd have plus 2. Adding 2 to both sides of the equation, a linear equation is y equals -4x plus 4. So we'll go ahead and write this as a function. We'll say L of x, the equation of our tangent line, is equal to -4x plus 4. So now we'll evaluate the tangent line at x equals 0.504 to make the approximation for our quotient. Let's go and do this on the next slide. For L of 0.504, we do want the exact approximation. So this would be 504 thousandths. But this does simplify. These are both divisible by 8. So this simplifies to 63 125ths. So we'll actually find L of 63 125ths to make our approximation for this quotient. So this would be -4, or -4/1, times 63/125, plus 4, or plus 4/1. Notice our common denominator would be 125, Let's multiply this by 125 over 125 to obtain our common denominator. So negative 4 times 63 equals negative 252 over 125 plus, this would be 500 over 125. So this is equal to 248 divided by 125. This would be our exact approximation, but let's also convert this to a decimal. This quotient is equal to 1.984. So using our tangent line, we approximated that 1 divided by 0.504 is approximately 1.984. Let's go ahead and use our calculator to determine the exact quotient and see how close this is. Notice how the exact value is actually very close to our linear approximation. And again, the reason this approximation is so good is because the tangent line is so close to the function when x is 0.504. I hope you found this helpful.